Welcome to qnawire.
In the first item, we have to calculate what is the transmission probability given that the barrier height is increased by 2%. So by increasing the barrier height by 2%, we get a new potential barrier that is 71.4 electron volts high. It's easy to see that this is the value because 1% of 70 is 0.7. And then 2% is 0.7 times 2, which is 1.4, and 70 plus 1.4 gives us 71.4. Then this is our new potential barrier. Now all we have to do is evaluate this transmission coefficient again. So we have T will be equals to exponential of minus 2 times the square root of 2 times the mass, which is 9.11 times 10 to minus 31 times U0 minus E, 71.4 minus 50, and we have to multiply this by the electron charge, so we convert both U and E from electron volts to joules. So we multiply this by 1.6 times 10 to minus 19. Take the square root. Then we divide all this exponent by h bar, which is 1.055 times 10 to minus 34. And also up here, we have to multiply by L. Following. So multiplying by L, we get this times 0.1 times 10 to minus 9 because of the nano prefix, and then our new transmission coefficient, let me call it T prime, is approximately 8.782 times 10 to minus 3. The original coefficient was T0 is equals to 0.010. So by comparing them, we get the following. T prime divided by T0 is equals to 8.782 times 10 to minus 3 divided by 0.01. This is 10 to the minus 2, so we have 8.782 times 10 to the minus 3 plus 2 is 1. So we have 10 to the minus 1, and this is approximately 0.88. Therefore, we have a 12% decrease by doing this very small increase in the potential barrier. Now in the second item, we have to make another thing. In the second item, we have to increase the thickness of the barrier by 2%. So this results in 1.02 times L. I'm not doing this calculation yet, and you'll see why I'm doing that. The transmission coefficient, the new transmission coefficient, is equals to E to minus 2 times G times the new L, which is 1.02 times L. This is equals to E to minus 2GL times 1.02. Note that this is just the original transmission coefficient, T0. So T prime is equals to T0 to 1.02. Therefore, T prime divided by T0 is equals to T0 to 0.02. Then it's much easier to evaluate the change. T0 is equals to 0.01. So this is just 0.01 to 0.02, which gives us approximately 0.912. And this means that there was an approximately a 9% decrease in the transmission coefficient by doing this transformation with the thickness of the barrier. The difference between this 9% and the 6% decrease is very small. It's only 3%, so they are of the same order of magnitude. And we have this difference because the book, when solving this problem, uses many more approximations than we are using here. so they get a less accurate value.